of problems. Okay, I just want to welcome you again now since the recording is in progress. Um, we are happy to welcome 36 participants at least, going on to a larger number. And I am very pleased to be here in the company of all the learners here who have qualified to this program. And you're obviously amongst the very good students, the top students in your division to be selected to come and join this program. Only those who are privileged to be here are here. Having said that, I want to remind you once again of a very important rule, and that is to have your microphone switched off. The little audio thing that you see on the extreme left, it's on my extreme left at the bottom, mine, and I presume it's the same thing with you guys. If at some time we suddenly get an interference, some dog barking or a mother calling you, then we will warn you, please take your mic off, and we'll do that only once. If that comes again, then Khotso will remove you from the room and put you into the waiting room, and we don't want that to happen. I don't want to have that embarrassing situation created, but that is left entirely to you. All right. So with those few words, let me share my screen with you. Okay, Kotso, can you all see the screen? Kotso, can you just tell me whether you can see the screen?
Yes, I can see the screen on my side.
All right, so I presume that all of you can. Okay, so let's go to the first problem. Now, you would have seen these problems because you've got the problem book, and you know that you're going to do session 2 today. And I asked you last week, I think, that to have a look at these problems before you come into the class. I always say that it's very important to try a problem first before listening to a solution. It is, it is an insult to the subject to look at the solution even before you know the question. All right, so with that in mind, we are not going to spend too much time over the question itself. Here we have 5 identical rectangles, which means that they are all exactly the same. Rectangles whose length and breadth are the same, identical rectangles. So you can see there are 5, 1, 2, 3, 4, 5. They're placed inside a square. As you can see, this whole thing is a square. And the side of the square is it's given that the square has got side 24. So we can say that this is 24. Okay. Now I see some people are coming in late. It's already 8 minutes past 5. Please bear in mind that the class starts at 5 o'clock. Each time you come, there is a noise on the screen. So it's a disturbance. Make sure you are here at 5 o'clock. Today we waited a little bit, but I'm not going to do that all the time. Okay, so the question is now, what is the perimeter of each rectangle? So you got these rectangles. So rectangle has got, we don't know what the length is, so let's just call the length, say, x, and we call the breadth y. This is x and y are the length and the breadth of the perimeter. We don't know what it is, but we are of the rectangle at least, and we need to find the perimeter of this rectangle. So the question is, what is the perimeter of a rectangle? Now you know the perimeter of a rectangle is you add up all the sides. So this the perimeter always means the sum of the full length of the boundary. So you got x plus y, and then you have another x on the other side, and then another y on this side. So you can see you got x plus x, which is 2x plus 2y. Okay, I always like to use symbols, and I presume by now you're quite familiar with symbols and how to manipulate symbols. X plus x is 2x. Now, you can take the 2 out. This gives you 2 into x plus y. The very important rule in algebra where you have, if you got a number multiplied by another number, which is a sum. This is a product of 2 numbers here, not 3 numbers. Product of this number and that number, then the product can be written as a times b plus a times c. So you can just multiply each of them by what is on the outside and add them. Okay, so this is a very important rule in algebra. So and conversely, if you got a occurring twice, you can take a out like this, open brackets, and what remains, you put it here, plus what remains, you put it there, right? So it works both ways. So that is why I've got the same 2 here. I can take 2 out into x plus y. And this is the formula which you're quite familiar with. It's twice into length plus breadth. I think you are just told that the perimeter of a rectangle is twice into length plus breadth, and this is what we've got here. All right, now you need to know what this is, just knowing the side of the entire square. Now, there are many ways of doing this, but the quick way of doing it is, if you look the vertical, only just the vertical lines in this diagram, this is y. This here is the long one, right? So it's the length. And this vertical line here, from here to here, is again the length. And this one here is the breadth. So you've got, if you just look at the vertical lines, you will see that you've got, and if you add up all these verticals, that, plus that, plus that, plus that, you're going to get the entire side here. And this is a square, so all the sides are 24. So in other words, you got y plus x plus another vertical line here, plus x plus y is 24. And bingo, this is 2x plus 2y. So without too much of fuss and bother, so we've got the perimeter. So that's the answer. Now, I didn't do it like this. I actually took the horizontals and had great difficulty in trying to piece all these things here together without noticing that we can get straight to the answer by just looking at the vertical sums rather than the horizontal sums. See, okay, so let's get on to the next problem. This is, it's easy if you know how. Okay, the next problem is determine the sum of all integers x which satisfy this equation. All right, now you got an equation which has got x's in it. So if you give x some name, then you can actually, like for instance, if one ex5, let's say, whatever, you've got your mic on, we are telling you for the last time to take it off. The next time that comes on, sir, we'll have to take you out of the class. So be warned. Okay, so you've got, yeah, if you say, suppose you had x, let x be equal to say 10, then this is 2019 minus 10 into to the power of, now this is the index, the power. So that's 2020 plus 10 gives you 2030, and that gives you, if you take away 10 from this, you got 2008, 2009 to the power of 2030, and that is certainly not equal to 1. You want this to be equal to 1. All right, so I'll just put a number there to get a feeling as to what is happening here. You've got this quantity here is raised to that power. Okay, now when can you have a power equal to 1? Suppose you have a to the power of x is equal to 1. Now there are some cases. The clearest case is a equals 1. 1 to any power is 1. Or x is 0. Now some of you might not know about this, but I can just tell you, right, that here's a fact. This you will learn, in maybe in grade 9. Some of you in grade 9 would already have seen this. And that is where you have powers, the any number raised to the power of 0 power 0 is equal to 1. Any number. 5 to the 0 is 1. Right? Now, this fact here comes in a section where in school, which is entitled indices, or sometimes it's called exponents. This power is called an exponent, and sometimes it's called an index. So you have an index and exponents. All right. So that is why you can have x equal to 0. So those are the two cases. So if you do that, you got, therefore, 2019 minus x. That one there can be equal to 1. The sign here means implies, right? I often use this. The left-hand side, from the left-hand side, you conclude the right-hand side. So this thing here, it says that given this, you can make a conclusion to that. See? So it's sometimes you can even say, if this is true, then that is true. So here, it's a simple equation. What must you subtract from 2019 to get 1? It's 2018. So this is a solution, right? But there is at least another solution, and that is where you have the index is 0. All right, so you have the second solution where the index is 0. It's going to create a little bit of space here. And when the index is 0, then you have that the index here is 2020 plus x equals 0. And there you can see that you leave the x's to one side. That is the general rule, x is one side, and take the numbers to the other side. When you take 2000, when you take a number across the equal sign, it changes sign. So the 2020, when it's taken across the equal sign, it's this. So you can see when you put x equals negative 2020, then you're subtracting those two, you get 0. Otherwise, without even that knowledge, you say, what must you add to 2020? You get 0, and you're not adding anything, but you have to subtract 2020, and that's where this number comes in. Okay, so this is also a solution. But there is one which is hidden here, right? And although I said that there are only two cases, there are cases where neither of these work. For instance, if you put the bases, this is called the base. If you let the base be -1 and you square it, then -1 times -1 is +1. Product of two negative numbers is positive. 1 times 1 is 1. So here you get, again, you get the answer is 1. But the thing is, if you got the base negative, if you take square, you'll get 1. But if you cube it, then you actually get -1, because then you're multiplying -1 by itself 3 times, right? So when you square it, it's 1. When you cube it, it's -1. So in general, if you take -1 and you have an even number here, an even number, then it's 1. And if you have -1 to an odd number, then it's -1. Because this is -1 times -1 times -1, an odd number of times. All right? So if you take any 2, it'll give you +1. And then if you got an odd number, in the end you have 1 times 1 times 1, and then you're left with one last odd number, which is -1. 1 times -1 is -1. Anyway, the point is that you can have this to be -1. 2019 minus x equals -1. You can have the base to be -1, but you must put and 2020 plus x is even. You can only have that case, right? When this is -1 and that exponent is even, only then can you have this. All right, so in that case, let's see, what does this say? Right, if you take the x to this side and take the -1 to this side, then you got 2019 plus 1. If I take the -1 across the equal sign, +1 at least. And this gives you 2020. Is it even when x is 2020? Yes, 2020 plus 2020 is even. So it is satisfied, and therefore this is also a solution.
So just a second, Prof. Apologies.
No problem.
Please. Interruption. Can I go ahead?
Yeah.
Yes, you can. I saw your comment.
Yes.
I was on it, but you can. It's just a comment, Prof. It's not a question.
Okay. Okay. Shall I continue?
Oh, sorry.
No, if we can check the comment, Prof. From
okay, let me just come in, David. Yeah. Just for the benefit of all of you, this is going to be largely a monologue, unfortunately, because we've got a fixed amount of time to finish a number of problems. But what happens is, if you have any question or any comment, you can go to the chat column, which is at the bottom of your screen, or at the top somewhere. Look for chat, and go to the extreme right-hand side and put down your comment or in the chat column. And at the end of this class, I will come back to all the chats and we will answer all those queries. And if there are any other queries, we'll answer them. But that will be only at the end of the class, unfortunately. Just hold on to your question until the end of the class, and then we will proceed. Is that understood? I hope it's all understood amongst all of you.
No, Prof. I just wanted to correct something on this solution. It's
I see.
It's not a question. Just check, Prof.
Oh, I see.
Yes.
This is 2020. I don't see anything wrong. Please ask the person to check it out, and we can talk about it at the end of the class. All right, I don't see anything wrong at the moment, but if there is, we can check it out at the end of the class. So we got the 3 clouds here. Those are the 3 solutions. And the question is, determine the sum of all integers x. which satisfy this equation. So I'm going to add all these three things, 2020 and minus 2020. They give you 0, and 0 plus this is 2018. So therefore, the answer is 2018. Okay. It seems that there may be an error in this. So at the end of this class, we can check it out. Okay, so the answer is 2018, as far as I can see. All right, so we go on to the next question. It is now 25 past 5. Khotso, I suggest that you close the class now, no more admissions. Sorry, but people must be here in time at 5 o'clock. And if they come in here at any time they feel like, then we have a problem. It's already 25 minutes past the hour. Okay, we're not allowing any further students into the class. It might be unpleasant, but we can allow just a certain amount of time, latitude, but not unlimited latitude. Because it's a disturbance. There's a noise that comes onto the screen each time new people come. So, all right. So the next question, now this is a new question. It is not in your problem book, but I put it in because it's an important question. So this is what this says is, how many factors does this number have? Right. We're not actually calculating the number, but without calculating it, we've got the factorization, and the question is, how many factors does this number have? Now, this is an important question. The interesting thing is that if you have any number like 12, for instance, you can write down all the factors. One of the factors is 1, and I normally write down the other factors straight away. 1 times 12, 2 times 6, 3 times 4, 4, but now we've already come to 4, so we don't need to go any further. So you can see how many factors does this have. This is number, the symbol, like that. Number of factors, as you can see, is 6. Right. So if you write down all the factors, then you can count them. But interestingly, you can get the answer without writing down all the factors. You can actually get the number of factors without actually writing them down. And this is how you do it. You factorize this. And you'll see 12 is 3 times 4. And you factorize it until you only have prime factors. So this is 3 times. 3 is a prime, so that's fine. 4 is 2 times 2. Now you have only prime factors. So every number can be factorized into only prime numbers. That is why prime numbers are very important, because all numbers can be, when you write it as a product, you'll get only prime numbers. You can write it as a product of prime numbers. And even better than this, you can group together the equal primes, and you write it as a power like that. 2 times 2 is 2 squared. I'm putting 2 in the front because I put it in increasing order. So this is 2 squared times 3. Right? So once you factorize it, then all you have to do to get the number of factors, you can get the answer straight from here. What you do is you take each of the exponents, you take 2, and increase it by 1. So the first exponent you increase by 1, you put a bracket around it because you're going to multiply it by, you take this exponent. The exponent here is not here, but it is actually 1. 3 to the power of 1 is 1. Right? So you take that exponent and increase it by 1, add 1 to it, and you multiply these numbers together. And here you got 3, and here you got 2. 3 times 2 is 6. Bingo. You get the answer straight away. See? So this is a very nice way of finding the number of factors of a given number. Like if you take the number 108, for instance, right? I'm not going to go through the whole process, but in the end, you're going to get 4 times 27, which is 2 squared. 27 is 3 cubed, right? And therefore here, the number of factors of 108 equals, increase 2 by 1 to get 3, times, increase this by 1, it's 4. The answer is 3 times 4, it's 12. So if you worked out all the factors of this, you'll get 12 factors, even without writing them down. So that is a very beautiful formula. And I'm not going to write down the abstract formula because that will only make it more confusing. But the moral of the story is that if a number is given in factorized form, right, in the product of prime powers, I call this prime powers because this is a power of a prime, right? If you write it like this, then you can immediately get the number of factors. Okay? All right, so you can admit this person, Kotso, and this is the last admission. I think we have to tell them at the end of the class that in future, if they come more than 15 minutes late, they would not be admitted. Okay. So in this case, yeah, this works for any number of factors. So if we look at this, the problem that we have it on hand, here the number of factors is, according to what we have just said, number of factors. First, to see whether it's written as prime powers. Yes, 11, 13, 17, and 19 are all prime numbers. All right. And the indices are all 1. 11 to the 1. All right. So you have to increase each of those indices index by 1. You get 2 times 2 times 2 times 2. And that is 16. So we can write down the answer immediately. We can say this has got 16 factors. All right. Without even calculating this monstrous number. It's obviously a very large number. It's more than 40,000. Okay. But as long as you have factorized it in this form, then you can write down the factors of that. Okay. So the next problem. Okay, now the next question is, if 2025 is divided by n, the remainder is 16. Okay, now we don't know what you are dividing it by. So you're dividing 2025 by n, and you have some number, and the remainder is 16. Okay, that's it. So the question is, determine all the possible values for n. So what are you dividing by? See? So this looks like a difficult problem, but if you just think about it, well, firstly, the remainder is always smaller than n. Right? When you're dividing, you always make sure that the remainder is smaller than n. So we can say straight away that 16 is less than n, right? But you also know that when you take away 16 from this, If you take away the remainder, then this goes into this exactly, right? You want to know n, how many times it goes into this. The remainder is 16, so if I push the remainder back into this, right? So you get 2009. So n goes exactly into 2009, and the remainder is 16. See? So now to know n goes exactly into 2009, so it means n is a factor of 2009, which means that we have to factorize 2009. Okay, now we're not going to go into the details with that. All right, and then let's try to factorize this. You'll have to try all the numbers. Try from 3, you try all the prime numbers. Obviously 2, try it. No, it doesn't work. 3 does not go into this because 2 plus 9 is 11. So you can skip 3, and you can skip 5 also because it doesn't end in 5 or 0. And the next number you try is 7. You see this is actually 7 times 287. And then you try to factorize that one, and you see that 7 goes into that also. So it's 7 times 7 times 41, right? So we can write down what the factors are. N is a factor of 2009. So from what we just said now, that there are 8 factors to this, because you got, no, wait a minute. The 7 squared times 41. The number of factors is 3 times 2, which is 6. You can actually write down all the factors of this. It's 177 squared, which is 49, right? 177 squared. Take all the factors of this, and then you multiply all these by 41, the next one. So it's 41 times 7, 41 times 1, 41 times 7 is 287, and 41 times 49 is 2009. Right. But you are only looking at those numbers where n is greater than 16. So you'll have to take this out. Because when you divide by 7, the remainder will be smaller than 7. So you have to take that out. So the only numbers that remain which are bigger than 16 are those 4 numbers. So determine all the possible values for n. The answers are here. The answer is 41, 49, 2087, 287, and 2009. So this is a problem which tests your understanding of division. What do you mean by division? Whenever division is a very, very important operation in mathematics, right? Especially when you're working with whole numbers, right? When you're working with fractions and all that, divisions don't play a very significant role. But when you work with whole numbers, you can always divide one number by another. You get a quotient and you get a remainder. See? So in general, you have, this is when you divide a number, let's say a number, capital N. You get a quotient and you get a remainder. So we use R for remainder, Q for quotient, and the divisor is N. Then we just saw that N minus R, if you subtract the remainder, then you will get the product of these two numbers. This goes exactly into that, Q times. So therefore, there is a formula which says N is equal to Qn plus R. And this is a very, very important formula which relates to the number which you are dividing into, and this is the divisor, and this is the quotient, and this is the remainder. So later on, when you do Olympiad mathematics grade 10, grade 11, this kind of things comes up quite often for you to understand what you mean by division. All right, so let's just get on to the next problem. Okay, now that we have a number of participants here, let me just make this announcement. I've made this announcement a couple of times. That is that the class starts at 5 o'clock. And if you cannot make it within the first 15 minutes, we are going to close the waiting room. I know I have to be compassionate, but unfortunately, this is how it works. If you want to be at this class, you have to come here by at most 5:15. If you come later, we would not admit you into the class. The reason being that each time you come into the class, there is a noise here, a bell sound, which everybody can hear, and it's quite a distraction. That's not the only reason. The other reason is punctuality is very important. Okay. So you have to make room for this. There could be some other important things, but make this your priority. Okay, so the next question is, Mary has 3 types of toys: teddy bears, cars, and jets. So she'll got 3 toys. All her toys except 21 are jets. Now, what do you mean by that? If she's got, put all her toys here. She's got a jet here, and you got a car here, you got a car here, and you got a bear here. Is it a teddy? We will call it T. A couple of teddies, a couple of jets, like this. All her toys, except 21, are jets. So it means that if you take the jets out, then the rest of the toys are 21. All the toys except 21 are jets. So if you remove the jets from all the toys, the number there is 21. So let's just understand this, right? It's a language problem. So we have to understand from the total, if you take away the number of jets, you're going to get 21. All right. So we don't know how many toys there are altogether. So let's give a name to the number of toys. We'll call it T, capital T for total. So this is equal to the total number of toys I'm using the symbol number again. Total number of toys, let's call it T. So what we've got here is the total number of toys. If you remove the jets, you got 21. So suppose now we don't know how many jets there are. So let there be, see, now you're giving names to symbols. Whenever you use a new symbol, you must describe it exactly like the way I've done it. T is the total number of toys. And I want to give a symbol to the number of jets. In this example here, I got the number of jets is 2, but in general, we don't know what it is. So let's call it small j, just to keep track. This is equal to the number of jets amongst the toys she's got. And likewise, if you use teddy bears, let's call it T. I'll call it T here in this case. This is the number of teddy bears. And then you got the number of cars, call it C. Okay. So just for these 3 pieces of information, you want to know how many jets she's got, right? Now, I know you learners are in grade 8 and grade 9, but mathematics is, the algebra is full of symbols and equations. So you have to get used to this thing to create equations. You have to create equations and create as many equations as you possibly can, and then use those equations to solve. Because once you got an equation, you can solve for it. Now, I don't know how far you've gone, but quickly, now if you had, if I just do something on the side here, we've got a lot of problems in this thing here where you got equations. So I just want to give you the basic facts about this. One important thing is that if you got an unknown, say you got 5x minus 3x plus 4x over 5 equals 16. You got an equation with one unknown, x, right? Then you got equation one unknown, you can solve for it. And the way to do that is, you got a fraction here. I don't like fractions. I can get rid of this fraction by multiplying right throughout by 5. I can't just multiply this by 5. I have to multiply everything by 5, right? That is the rule. So you multiply this by 5, 5 times 5 times x, 5 times 3 times x. 5 times this is just 4x, because the 5 is cancelled. 5 times 16 is 80. And then you can get all the x's together, and you go 25x plus, when you work this thing out, you get 14x equals 80. Now you got 14 times x is 80. So x must be 80 divided by 14. And there it is. You can solve for x. In other words, this process allows you to solve for x. If I had something else, if I had x plus 2 equals minus 3x plus 5, or minus 3 plus 5x, say, then the way to do that is to bring all the x's to one side. And I said earlier that when you take 5x on this side of the equal sign and bring it to the other side, that sign changes. This plus 5x becomes minus 5x. So all the x's to one side, and here you got minus 3 on this side, and this 2, there's no x in it. You can take it to the other side, but you have to change the sign. So now you have all the x's to one side, now the numbers to the other side, and you proceed as we did there. Right. That's a very quick way of explaining what happens in what we call these equations, these linear equations. So we've got 3 things here. We said the total number minus the number of jets is equal to 21. I said this earlier on. If you take the total number and you remove the jets, you're going to get 21. So in exactly the same way, the total minus the number of teddy bears, that's the second fact, just finished with that one, is 23. And then you have the total number of toys minus the cars is 26. So you got these 3 equations, J, T, C, but there are 4 unknowns, right? Now remember what T is. T is actually equal to the total number. So you can say it's J plus T plus C. Right? If you add up all the number of jets and the number of teddy bears and the number of cars, then you get the total. So you know that when you add all the 3 quantities here, you're going to get capital T. So now you can see I got a minus J minus. So why don't I add up all these things? Add both sides. All these are equations, so you can add. Now this is observation here. It's a trick. The reason being that I can see I'm subtracting J, I'm subtracting T, subtracting C. So I can add up all these things. The 3 T's gives you 3T. T plus T plus T is 3T minus a minus sign in front of a bracket gives you minus J, minus T, minus C. So I would have had minus J, minus T, minus C. I'm taking this thing out straight away. We're adding all these. So when you add all these, right, you'll get 70. Now J plus T plus C is what is actually capital T. So 3T minus T is 70. Right, so there it is. Now you got one unknown, 3T minus capital T, and you got an equation. So 3T minus T is 2T, is 70. So 2 multiplied by capital T is 70. So that tells you that capital T is 70 divided by 2, which is 35. Okay, so we know what the total is. It's 35. And the question is not asking for the total, it's asking for the number of jets. So just remember, we need to know what the number of jets is. Now, where do you have the jets? The jets are here. The jets are here. So you got the T is 35 because you got 2T is equal to 70. So now you take that equation. The first equation tells you has got a J in it. So it's 35. You can put your value of T into that. 35 minus J is equal to 21. Now you got one unknown here. Right? How do you do this? You take the minus J, leave it on one side, and you got 21, and you take the 35 and put it to the other side. So you got minus J, 21 minus 35 is negative 14, and therefore negative J is negative 14, so J is equal to 14. And that is equal to the number of jets. So this is the answer. Okay, normally what I do is, when I see a negative sign here, I push the negative sign on, I take this negative and mentally I put the J on that side. And then I go 35 minus 1 on this side. And 35 minus 21 is 14 straight away. So I mentally, I do that. And instead of writing 14 equals J, I put J equals 14. So normally I take the unknown, if there's a negative, and I push it on the other side so that I have a positive unknown. But if you don't like that, you can do it like this. It takes a little bit longer while. Okay, so that takes care of that problem. Now, this is the first time we come across an equation, or quite a few equations, and you got unknowns, and we are solving for the unknowns. In this particular one here, we have to dissect this problem into small pieces so to understand what is given, and then you write down the equations. So these are very crucial, writing down those equations. And the third equation is, fourth equation is T is equal to J plus T plus C. So that's also an equation here. Okay, and then you look at all your equations, say, how should I solve them? And go ahead and do it. Okay, so that takes care of that problem. And let's just get on to the next problem. Okay. Now, from now onwards, you're going to have a lot of equations. You take the information that is given, put unknowns, and then create equations. The process is, look at the information that is given, right? Normally, it doesn't make any sense. You see what the question is. The question in this particular case is, what is the total of Ali's numbers, right? So bear in mind, there is some question here. And then you read your information and you ask yourself, what symbols must I use for what? So now you got, Eve chooses some numbers. We don't know what numbers she chooses from this set. So she could be choosing, a few numbers here, 4, 8, 16, and 128. So we don't know what she chooses. And Ali, I presume that this is the way you say it, Ali takes the rest. So what happens here is that this set here is divided up into two parts, one which Eve takes, and the rest is Ali takes. So it's quite important to understand that. So we've got Eve's numbers is a collection from here, and Ali's is whatever remains. But the total of Eve's numbers now you're talking about the total of Eve's numbers. So that's a number. So let's give a name to that. We'll call it E. Sometimes I like to use symbols like this, because then I keep track of what the symbols mean instead of going back to find out what it means. When I say capital E, I know immediately I'm talking about E is the total of Eve's numbers. So we have to understand that this capital E is, we take all the numbers that she chose, we don't know what she chose, but the total of that is E. And 31, and Ali's is, we'll just call it A. That's also got a total of Ali's numbers, right? And it's given that Eve's total is 31 more than Ali's. So it means that E is more than Ali's by 31. So that's your equation, right? So whenever you have an equation, you should have a smile on your face because you're coming towards the answer to the problem. You have an equation. But I got one equation with two unknowns here. So E minus A is 31. And the question is, what is the total of Ali's numbers? So the question is, that's your question. It wants to know what is A. That's the numbers. We give the symbol A to the total of Ali's numbers. So we've got one equation with A in it, but we don't have any other information. But here is where the problem solving comes in. When you add Ali's totals to Eve's totals, Eve's is sum of these, and Ali's is the rest. When you add these two, that means you're adding all these, the whole lot. So when you add Eve's total to Ali's total, then you're really adding the whole lot of numbers. So Eve plus A is the sum of all these numbers. And you can work out what these numbers are. You can add the sum, and my answer is 255. So now you got E minus A is 31, and E plus A. So let's just put this down. E minus A is 31, and E plus A is 255. Now, you've got two equations with two unknowns. And usually when you have two equations, two unknowns, or three equations, three unknowns, you can solve for them, right? You just need the number of equations must be the same as the number of, not always, but generally. In problem solving, sometimes it doesn't happen. Sometimes you have fewer equations than unknowns. So you've got more unknowns, and that makes the problem a little bit difficult. But we'll see some of them just now. So you've got this. So how do you solve this? Now, if you want to get A, what you can do is you can subtract these two. E minus E gives you 0. So that'll kill E. So we can kill E by subtracting. So E minus E. Right? And when you subtract these two, you got minus A. And you're subtracting A. So that's minus A again. Minus A, subtracting. And you got 31 minus 255. So you subtract both equations, E minus E. The reason why you subtract is when you subtract them like that, E minus E disappears. Right? So that unknown is gone. And now you have only one unknown, and that is minus 2A. Minus A is minus 2A. And 31 minus 255, if you look at it, that's 31, it's minus 224, I think. Right. So minus 2A equals minus 224. Now you've got one equation, one unknown, and that's exactly the unknown that you want to get. So it's negative plus 2A is plus 224. So 2 times A is 224. So A is 112. It's just half of it. So that's the answer to this problem. So this is a nice trick. If you needed to calculate E, then you simply add them, because those two will, A minus A will disappear. Now this kind of problem occurs quite often. In grade 9, you will solve problems like this, or even grade 10. But I'm not going to go into all that. I'm looking at only those equations, and you will understand the principle here. The idea is to get rid of one of the unknowns. You've got two unknowns, you want to get rid of it. How do you get rid of it? You can subtract to get rid of the E, or you can add to get rid of the A's. You see? So one of the ways of doing it is you just add or subtract or do something to it to get rid of the one of the unknowns. All right, so that takes care of that problem. I'm going to get to the next problem now. Okay, so again, you've got a problem. In a class test, each learner scored 1, 4, 5, or 8 points. All right, I would say marks, but anyway. So each learner scored, so some learners scored 1 mark or 1 point, and some scored 4, some scored 5, some scored 8. Nobody scored 7. So these are the only scores that they've got. Right, but we don't know how many learners there are in the class. So some learners scored 1, some learners scored 4, some scored 5, some scored 8. The number of learners who scored 4, all right. So we don't know what that number is. So what we're going to do now is I'm going to do it like this. The number of learners, and I'm going to put a score underneath it. You'll see just now why. So we'll say there were A learners. Let's call these symbols A now. And A learners scored 1. Right. So the number of learners who scored 1 is A. We don't know how many scored B 4, so we can do the B scored 4, C scored 5, and D scored 8. Right? So we can do that kind of a thing, and sometimes it might be nice to put it neatly into the form of a table like this, and that gives you the information very quickly as to what the A and the B and the C mean. So now you can say A scored 1, B scored 4, and so on. All right. So this student comes in 2 minutes past 6. I think you can admit this student. Obviously, I think the student had a class at 6. Oh, no, let's just stick to it. We don't admit them. Okay, now let's carry on. The number of learners who scored 4 points, that is, the number of learners who scored 4 points is B, is the same, equals the number who scored 5. The number of learners who scored 5 is C. I have an equation. Happy. Right. Now, the total number of points scored by the class. Right now, what is the total number of points scored by the class? Let's just take one of the examples. So suppose if there are C pupils who scored 5, so what's the total scored by this group? Right? If there were 2 people who scored 5, the total is 5 times 2. If there were 6 people who scored 5, the total is 6 times 5. So therefore, the total number of points scored by this group is 5C, 5 times C. In the same way, you've got A times 1, 4 times B plus. So you're adding up all the total number of points scored by the entire class now. So I'm going to add all that, A times 1 plus 4 times B. That gives you the total number scored by the B, and the total scored by C, and the total scored by D, right, is 8 times D. Just go again over that. If there were 6 people who scored 8 points each, they contributed 48 points to the total. And like that, each one contributes so much to the total. And to work out the total altogether, you add all of them up. So what's about this? The total number is 63 more. So this is equal to 63 more, 63 plus what? The number of learners in the class. So the number of learners in the class is, how many learners are there in the class? You got A, B, C, D. So that is, it's A plus B plus C plus D. Right. So you've got, this is the total number of, I've got an equation, a second equation, and again I have a second smile on my face. The 4 unknowns, only 2 equations. Oh, you need to have 4 equations. This is not a very happy state of affairs. So let's see what we can do with this information. I'm going to take this bracket out, 63 plus A plus B plus C plus D. Please admit Bradley in is one of our Khotso, did you get that? Khotso? David?
Yes, Prof. It's me. I've done it.
Yeah, please admit him. He's one of our center managers. Okay, so I've got 4 unknowns. And so let me get all the unknowns together to one side. A, and I take this A here and put it to the other side, and I get A minus A. That's 0. I'm not going to add that. 4B, and the B, when it gets to the other side, you get 4B minus B, which gives you 3B. And 5C, you take the C to the other side, it becomes minus C. So 5C plus minus C is 4C. And 8D, when you take it to the other side, you got 8D minus. So I'm taking all the unknowns and putting to one side, and I leave the number to this side. Now I've got one equation with 3 unknowns, but B is equal to C. So let's make B equal to C. So you have 3C plus 4C. So you have 7C plus 7D equals 63. I'm now using the fact that B is equal to C to get this. I can replace the B by C now because they are equal. The 3C plus 4C is 7C. And even this too I can simplify because this is 7 times C plus D is equal to 63. And 7 times C plus D is 63. So C plus D is 9. Oh gosh, I still got 2 unknowns. So I can't solve. I got too many equations. What is the question? The question says, how many learners scored 5 or more points? 5 or more points. Which learners scored 5 or more points? These are the ones who scored 5 or more points. And how many learners scored 5 or more points? It will be C plus D. Bingo, because we know what C plus D is. So the question says, what is C plus D? That is the question. How many learners scored 5 or more points? So we just worked out C plus D. So the answer is 9. It's a nice problem because you got 4 unknowns here, but just by trying to translate the given information into equations. So very, very important, right? To translate into equations and then solving it. Here we had a bad example because you got 4 unknowns, but we just proceeded and we landed at the answer because the question did not require you to tell, it didn't ask what is C and what is D. Right? So we don't have to know what C is and what D is, but we know what C plus D is. All right, so that goes on, that takes us to the next question. Okay. Oh, we finished this one, so let's, all right. The number 16 is placed in the top left corner of a 4x4 table. So there you got a 4x4 table. The number 16 is placed in the top left corner. I've got a magnified version of this. The top left corner will be this one. So there is 16. The remaining 15 squares And let's not worry about the shaded part yet. So you got 16 squares altogether. The remaining 15 squares are to be filled using each of the numbers 1 to 15 only once. So we don't know where they are. You can put 1, 2, 3, 4, 5. But but each square, each number must be used only once. So the 15 squares will have 15 different numbers. And it has to be from 1 to 15. So all the numbers 1 to 15 are in these squares, right? So that the sum of the 4 numbers in each row, this row, when you add all this, the sum, and when you each row, so this sum, this sum, this sum, this sum, the sum of the numbers in each row, and the columns, this sum, that sum, that sum, that sum. There are 8 sums already, and each main diagonal. So this is a diagonal here, and this is a diagonal. And normally this is called the main diagonal, and the other is a secondary diagonal. But anyway, they say each diagonal, that's all are the same, but they don't tell you what it is. So suppose we know this sum here is x. So this sum here is also x. This is x, x. So x is the sum of 4 numbers, and this 4, and this 4, and this 4. So it means that when you add all these numbers, you're going to get 4x, because x is the sum of 4 numbers. So that gives you 16 numbers, and that is 1 plus 2 plus 3 all the way up to 15, together with this number here which we stuck in, 16. So these are 15 squares which you filled in. So 4x is this, 1 plus 2 all the way up to 16. Now this will take a little bit of time to add up 1 plus 2 all the way up to 16. So I'm just going to take a little bit of time off to say how you can actually add this quickly. Okay, now just remember what I'm going to say, because this is quite important. Let me just detract for a moment. Your book called something, Siyanqoba problem book or something like that, which all of you got, right? If you take that book, it might come, it probably came as in an electronic form, but you go towards the last page, I think right at the end, some page 54 or something like that, you will see hints to solve problems. I just want you to go and read that, and for different problems you got hints. And I'm sure in this particular problem, which is session 2, problem something, there is a hint, all right? And it gives you a formula. So I've got several formulae in that. Go to that and pick out the correct formula. But now I'm not going to use any formula. I'm going to tell you how to work this thing out. You're going to add 1 plus 2 plus 3 plus 4 all the way up to 16, 15, 16. I don't know what this is. If you want, you can add it up. It'll take you a while, but you can do it. But if you add 1 plus 2 up to 1,000, then you can't do it like this. You can, but you'll die of old age by the time you come to the answer. Now, I'm going to do a trick here. Now, this was actually done by a 10-year-old boy a long time ago, maybe 300 or 400 years ago. A 10-year-old boy whose name was Gauss, right? Carl Friedrich Gauss, I think his name was. And he was not paying attention or something in class. So his teacher told him, now, Gauss, go out of the class and add all the numbers from 1 to 100. Right? And that is after school. So this boy, he said, how the heck am I going to add all these things up to 100? I'll die of old age. So he figured out a way. He said, I don't know what this number is. We didn't call it X, but he says, I don't know what this number is. But I noticed that if I write it backwards, and add all these numbers, 16 plus 15, I must get the same answer. So he said, I'll get the same answer, obviously. Then he says, but if I add both of them, then I'm going to get twice the answer. But I can add this way now, you see. I can add 1 plus 16, 2 plus 15, 3 plus 14, 4 plus 13, and so on. And bingo, he's got the same number added 16 times because there were 16 numbers. So then he says, well, whatever this number is, when I double it, it's going to be 17 times 16. And therefore, I prefer using 16 times 17. And therefore, your number will be 16 times 17 divided by 2. It's twice that number. And 2 goes into 16 8 times, and therefore X is 136. Very clever. Now, that idea is used when you go on to do grade 10, grade 11. You will come across a whole lot of problems of this type. But remember, the principle that Gauss used was you'll get the same sum if you add them backwards. And that allows you to get a beautiful formula. So in this case here, if he had n numbers, I just want to write this thing down because it's quite important. So if I add n numbers rather than 16, right, you can do exactly the same thing. It doesn't really matter whether you got 16 numbers or 50 numbers. You can do exactly the same principle, and you're going to land up with 4x. And if you're adding up to n numbers, okay, suppose we said you're adding where n is not given. In my problem, it was 16. Then what you get is, somebody is writing on my page. Who is that? Please don't do that again. Okay, so you got 4x, and what have you got? 16 times 17. So it's n times the one after that. Oh, I'm sorry. It's not 4x, it's actually the sum. 1 plus 2 up to n. Is equal to 16 times 17 divided by 2. So this is a very important formula. Lenovo, you are writing on my page. Also, if he does that again, please take him out of the class. So this is a very important formula. When you add the first n counting numbers, there's a very easy way of calculating it, and that is 1 plus 2. I'm not going to repeat this thing. Each time I see a thing like this, I will expect you to tell me straight away the answer is the last number times the next number divided by 2. All right? So please remember this formula. So in this case here, we got x is 136. 4x is 136. So x is, what have we got here? It's supposed to be 4x. 4x is the sum of the whole lot, and that is 136. So x is 34. Okay. All right, now I just want to clear out some of these things. That means the sum of each row, the common sum, or the common, there are 10 possible sums, the 4 rows and the 4 columns. We now see that that common sum is 34. So all these things, this adds up to 34 and so on. Now, I haven't looked at the question. I'm just analyzing. I normally do this, analyzing the information, and then ask myself, what is the question? What is the sum of the 6 numbers in the shaded squares shown in the diagram? Oh, so you got these 6 squares. That looks like quite a problem, because you don't know what these numbers are. They are randomly placed, 1 to 15. So what is the sum? Okay, this is very similar to the previous one. That, what was this? Eve and Ali, because here you got the shaded and unshaded. So you got 2 types here. You got shaded sum, and that is what we needed. Sum, let's call this S for shaded sum. And then you got the unshaded sum. Let's call it U for unshaded. So the question is, what is S? See? All right, so if you add up all these, S plus U, okay, a quick way of doing it is, like these 3 numbers add up to 34. Well, these 3 numbers add up to 18, because there's 16 here. So these are the unshaded ones. Let me try and add up all the unshaded ones. So these 3 again add up to 34, those 4. So that's also 18. And the diagonal is also 18. So you got the sum of all the unshaded parts. The unshaded is 16 plus 18 plus 18. 3 times. And that gives you 70. So you can use the 16 to calculate the remaining unshaded parts, and you get, so the total unshaded part is 70. So, but we know that S plus U, the shaded and the unshaded together, is 136. That is 1 plus 2 all the way up to 16. So therefore, we've got U, so U is 70. Right? So I can replace the U by 70. And there it is. You got one equation with one unknown. I'm sorry, this is 136. S plus 70 is, so S is 66. And that was the question, to work out the shaded sum. You see, the trick is to give a name to the shaded sum. Like what we did earlier on, we took all Eve's total and we gave it a name. Even if you don't know what the individuals are, you're only interested in the sum of all of them. So that way you only have 2 unknowns, the shaded sum and the unshaded sum, and then you use the information to eventually calculate each one of them. All right, so that takes care of that problem. Now we get on to the next problem. Now this one, I'm going to skip this one here because this is a little bit, the equations are a little bit tricky here. I'm going to skip this. Maybe you guys can try to do this on your own, and when you get stuck, you can speak to your center manager or a tutor who is assigned to you. Each one of you has a center manager. Make sure you know the name of the center manager and the contact numbers or the email address. And the same with the tutors. Make sure you have their email addresses. So you can feel free to write to them and tell them, sir, I don't know what to do about this problem. This is what I got. You must tell them what what you calculated, or you can phone them and tell them, and then they will tell you, okay, I'll come back to you, and then you can get that cleared out. So I'd like to give this problem here as it's a challenging problem, but I'm going to give this to you as your assignment, or not assignment, your homework. Your assignment is already there in the book. Assignment 2, session 2 assignment will be under assignments at the end of the book, and that problem you have to solve it and give it back to your center manager as quickly as possible within the next couple of days. He will tell you what the deadline is. Okay, so this particular problem here is you can do this. This is not an assignment. I will just call it homework, and you can consult with your center manager. Okay, let's get to the next one. The next problem is this one. An S by S square. Okay, I've actually drawn the square here. So S by S, in other words, it's got the sides are S, 4 by 4, 5 by 5, or whatever. S is an odd integer. Okay, you better just make a note of that. S is odd. Is divided up into 1 by 1 unit squares. Oh, so you just draw, it'll have S columns and S rows to divide this thing up into unit squares. So I'm not going to do it, but just to show you what's going on here, so it's divided up into like that, and then vertically. So you got, these are 1 by 1. So you got S, 1, 1, 1, 1. They all add up to S, 1, 1, 1. All add up. This is 1 by 1 unit squares. Right. So and then all the unit squares along the edges. So the yellow part, those are the square edges. They are removed. Now this person is coming 3 minutes before the end. I think he thought he's starting at 6:30. All the unit squares along the edges and the 2 diagonals are removed. I've got those as well. Find the number of squares if S is 103. Okay, so what you have here is that S is 103. So now you will notice that 2 ones are removed from 103. So this is 103 here, and this is 101. So this square here, which remains inside, those are removed. So the red square is what remains. But not only that, the 2 diagonals of the middle square also removed. So the question is now, how many squares are there remaining? So we have to count the number of red squares. Those are the things that remain. Well, you can immediately see, as I saw, that those 2 ones are removed here. So this is 103. So the red square is 103 squared, or 101 squared. But the 2 diagonals also removed. Now, how many are in this diagonal? The number of, this is not Pythagoras, huh? Just the number in the diagonal. Look, if you have the number in this diagonal is exactly as the number in this row. if I had a 3 by 3, and I just removed the diagonals, how many are there in the diagonals? You'll see it's that one, that one, that one from each row. See, it's one from each row. So it will be, you have to remove 101. So this 101 is removed from here. Another 101 is removed from here. All right? But you'll notice that this part here is counted twice. I removed this twice. That's not fair. I can only remove it once. So since I removed it twice, I have to add it back. Add that one back, right? To make it removed only once. See? This is a tricky part. Okay. This requires ingenuity, because you're adding, you remove it one particular one twice, so you're not allowed to do that. You must add it back, add that one back, so that you remove it only once. So this is 101 squared minus 201 plus 1. Now you can do this. It's 101 is a common, minus 201. Okay, now you calculate is not allowed. So this becomes, this is where the trick is, because this is really 101 squared. It's actually minus 202, sorry, minus 202. So I can't say this is actually minus 2 times like that. Oh, sorry. 101 squared minus twice 101. Now, here you can take out the 101 as a common factor. So it's 101 minus 2. 101 goes into this 101 times, minus 101 goes into this 2 times, plus 1. So this is 101 times 99. That's a nice thing. The subtraction can be made into a multiplication by taking out a factor. And then that becomes, you convert a subtraction to multiplication. That's what factorization is all about. Factorization is writing something as a product. Now this one here is easy to multiply. 99 times 101 is 9999 plus 1, and that is a nice answer, 10,000. So that's the answer. Okay. So once you know how to calculate it, then it becomes quite easy. But I just want to point out something here, that you could have done this in another way quickly. I don't have much time. Oh my God, I don't have any time at all. Okay, I'll finish off. I think I just got one more. We'll do that next week. But I just want to say this, that this part here, 101 squared minus twice times 101 plus 1, there's a nice, it's like a squared minus 2a plus 1. If you replace 101 by a, so a squared minus 2a plus 1. And this is the same as a minus 1 all squared. And those are in grade 9. I think you already know the square of a binomial. A minus b all squared is a squared minus 2ab plus b squared. And this is a very important square of a minus b times, this is a minus b times a minus b. If you multiply it out, you get this. So you have a little formula here. A squared minus, multiply the 2 and double it, and then it's b squared. So here you got a similar thing, so a minus 1 squared. So I could have had, this is 101 minus 1 all squared. And this is 100 squared, and 100 squared is 10,000. I could have done it that way, but you could have done it like this as well, which is more understandable. All right, so we've gone 4 minutes ahead. Next week, I'm going to do this problem, but in the meantime, please have a look at this this problem, because it's not next week, it's actually next month, I think. This is quite a challenging problem, but I'm going to do this. But I'm not going to do the other one that I gave you for homework. I'll do this the next time because it's a challenging problem, but you can try it. It'll be very interesting to see whether you can do this problem. It's quite a tough problem. I'll put this thing also for the seniors. Okay, so as concluding remarks, thank you very much for being here and spending an additional 5 minutes with me. Next time we will start with this last problem and go on to session 3, right? And the next time we meet, go and look at your program. I think it's in July, somewhere end of July. Not sure exactly what the date is. And then we will meet there on another Wednesday afternoon from 5 to 7. And we go back as normal. And after that, we meet once every 2 weeks. Okay, so I'll just see you occasionally to give you enough time to go over the problems. One other thing, this whole program has been recorded. And if you get stuck with something and you didn't follow what I was saying, you can go back to your center manager and say, look, I didn't follow a certain question. Prof Pillay was going too fast. Can I please have the recording? And then he will send it to you, and you can go to that particular recording, and you can go to the question or the questions and go over them. So it'll be, you have a recording, 1.5 hour recording. You can go to any question, and you can go and check it out and make sure you know how to solve every problem. That is the only way you can say truthfully that you have benefited from this class, not by coming and just sitting here and going back without going over what I told you. Okay, thank you very much for your attendance, and you can leave now, except those people who have got some questions. I just want to see if there's anything in the chat column. David, is there anything in the chat column?
Yes, it's that comment we talked about. It's just the additional statement, actually. That's you can check the first one is the only one. From Mosa.
Okay, from Mosa. Any number excluding 0, please correct. Mosa, are you there?
Yes, Prof.
Yeah. Yeah, okay, we are saying a to the power of n. No, you're quite right. I said that we said something like this, a to the power of n equals 1. And we said you can have any base to the power of 1 is 1. And you're quite right, except 0. 0 to the power of n is not equal to 1. Okay. All right.
Yeah, but 0 cannot be a base.
No, 0 can be a base. 0 to the power of 30 is 0 times 0 times 0, all the way to the power of 30. And an exponent means that you're multiplying the same number by itself so many times.
No. What I meant, Prof, is when the power is 0, you cannot have a 0 as a base.
Yeah.
Yes. So the exclusion was for that, for A.
Oh, I see. Yeah.
Exclusion is for A to be a 0 when n or the power is a 0. Thank you.
No, you're quite right. So when you calculate this thing here, you don't want this to be 0. And we saw this thing was 2018. So that fits, right? When you calculated it, we see that A is 2018, and that's not 0. So you're quite right. A to the power of 0 equals 1, we must say, is true for every A except A not equal to 0. Every real number.
Just that line of effect, Prof. Just that line. Yes. If we just exclude A as a base, not to be a 0, then everything else is fine.
Yeah. But actually, I'm looking at this particular problem where this is equal to 1. Yeah, this 2019 minus x is something. Now, you can make this equal to. You see, the thing is, in the end, I'm saying that this is equal to 1. Which number raised to the power of 1? But you are talking about this one here, 2000 and so you see, when this is 0, then x is negative 2020. All right. So there's a specific value for x which gives you the exponent 0. When you put that x value here, you get a number which is not 0. So that's fine, you know. But when you make a statement like what I just said, like this, if I say a to the 0 equals 1, for every real number a, that is false. I have to say that for every real number except 0. So this statement that I said is not right. But as far as that particular equation is concerned, that's fine, because when you make the exponent equal to 0, the value of x becomes very specific. It's not arbitrary anymore. It's negative 2020. And for that particular value of x, this is not 0, so it's acceptable. All right. I hope that clarifies that, Lisa.
Yes, thanks, Prof. Perfect.
Yeah, okay. All right. Thanks for that remark. This is an important point. Also, in this class, is it Moise, was it? Yeah, in this class, because these are juniors, I don't go into all the intricacies. I will make some statements which are not totally true, but it becomes clarified at later stages, you know. There are some statements which I make which would not be true, but if I go into all the details, then it clutters it up. So you have a general overall picture of what's going on, and then later on you get the refinements, you know. Yeah, sometimes I don't say it's not equal to 0 or what. Yeah, there are some times I do that, but generally I try to be as exact as possible. All right. Oh, there are quite a few other chats here. Let me just quickly look at the other ones.
No, I think it was general questions. It was not regarding to the class. I responded.
Oh, I see. Oh, you responded. Thanks very much.
Yes.
Oh, I can't see the screen.
It was general.
Yes, oh, okay. Thanks very much, David, for sorting this thing out. All these are more administrative questions. Yeah. So there are some promises you made. I will share the list on emails again. And okay. Thanks for answering all these questions. How do I find my center manager? They will get that information from you. Okay, now I hope you the rest can leave, but also don't kill us off. You can stop the recording. Oh, you can stop the recording, please.